Hello, I'm JW. This is part one in a series on the Brown book, and by Brown book we're talking about this thing, BS7671 18th edition, Amendment 2. This was published in March 2022, and that comes into effect 6 months from that, although you can obviously use it before that if you want to, but that 6 months is when it replaces the previous one, which was the blue one. It came out in 2018. Now, in this particular video we're going to be looking at parts 1, 2 and 3 from this book, and we'll cover the other parts and things in future episodes. And before we get to that, just a note that there is the on-site guide, also in a brown cover, to go with it. And there's also the Guidance Note 3, again with the brown stripe along the bottom there. Other guidance notes are not currently available at the time of making this video, but they will be published throughout the rest of this year. So that's numbers 1 through 8. But for this time, we're just going to have a look at the book itself. So let's get to that with parts 1, 2 and 3. So here's the Brown book, and it says at the top here it's Amendment 2, published in 2022, 18th edition obviously, as we've seen previously. Now, a couple of changes here on the outside. This one has this weird shiny lamination over the cover for some reason. That's really the first time they've actually used that. How long that stays in a decent condition remains to be seen. And the other thing here is if you're going to buy these, and of course you certainly should be buying it if you're in the electrical industry in pretty much any way, is that you do need to buy these from approved sources, because unfortunately there are fakes of these around. You don't want to be buying one of those. They may be cheaper, but there's good reasons for that. They may not contain what you expect. So there is a list of the approved vendors on the IET website. You can buy it from the IET directly, or there are obviously other places as well. And it should have one of these holograms inside the front cover. So there's that. Although of course on its own that doesn't mean anything, because they can be faked just as much as anything else. Now in terms of the layout of the book, it's pretty much the same as it's been in the past. This one goes to over 600 pages now, so there are a lot of extra pages compared to the previous versions. But in terms of the general layout, it's pretty much the same as before. Parts 1 to 7, there is a new part 8 now, which we'll cover in a later video, but generally the structure and layout is pretty much unchanged from previously. And this time we're going to have a look at parts 1, 2 and 3. There's not a lot in part 3 to look at, but we'll have just a quick look through that anyway. Any changes in this one are indicated in the margin with this vertical line, so you can see there's a few items in the contents there, and further into the text it's just again marked with these vertical sections to indicate things that have either been added, changed, or in some cases deleted completely. Now we'll start with part 1. This is Scope, Object and Fundamental Principles. This is a fairly short part, but it is actually very important because again it covers all of the fundamentals which apply throughout the rest of the book. And there aren't a huge number of changes here, but we'll just have a quick look and see what we've got. Now the first item of note here is 110.1.2, and we can see here that a few changes marked. This is an example of something that's been changed, but it's actually completely irrelevant because all that's changed here is where you've got the word premises. It's got single quote marks, and previously it had double quote marks. So although it's a change, it changes nothing, completely irrelevant. So we'll see as we go through this book that we're going to actually ignore some of the mark changes simply because of things like that, where it really doesn't have any effect on anything. However, what does have an effect is down here, we've got this new item here. So the regulations include requirements for prosumers, low voltage electrical installations, abbreviated to PEI, including those located external to buildings. This is actually covered in the new part 8, and we'll be seeing that in a later video, so we're not going to cover that here. And then a little addition here. Fixed wiring and all this was already included, but now it also includes fibre optic cables. So as well as data cabling to obviously copper wiring, whatever else, it does include fibre optics, which are either made out of glass or plastic. So that's now in the scope. And that's particularly important when it comes to installing them, so things like installing them in escape routes and premature collapse and all of that is now applicable to fibre optic cables, just as it is with any other kind of cable. A couple of items here, 110.3. This change here is one of these not particularly relevant ones. All it says now is the 60079 series. Previously it just said 60079. That's really just a minor correction. 60079 is one of these standards. It's not just a single one, there's a whole set of them, so it covers the entire set obviously rather than just that one, so a fairly minor item. And again here we've got exclusions, so this is the same as it was prior, so it doesn't cover systems for the distribution of energy to the public, but it does include prosumers installations covered by Chapter 82, and again that's the new one which we'll look at in a later video. So although it's in exclusions, it does not exclude prosumers electrical installations, which a bit confusing, but just an addition there. A few minor changes here, mostly to just punctuation, whatever else, but we've got the new Part 8 included in here, so as you would expect. So Part 8, functional requirements, and that's the prosumers electrical installations. Now 13121, this is basically the same as before, it's actually basic protection. What's been deleted here is a note which suggested that basic protection is the equivalent of direct contact. Now direct contact is a fairly old term which was actually removed quite some time ago, but there used to be a note there just implying that that's what basic protection now is. That and quite a lot of other things have been removed now because they're basically obsolete and have been for years, so there's a few of these where those have been deleted. We'll see some of those in Part 2 anyway, so we'll cover those there. This note has been amended in protection against voltage disturbances and measures against electromagnetic disturbances. This is now protection against straight lightning strikes on the structure or nearby lightning strokes. Refer to the BS7671 series. Previously this was still there, but it just said for protection against lightning strikes, so it's been expanded to cover onto the structure or nearby lightning strokes, which are things onto the ground. So it's not just about things striking a building. If you get lightning in say a nearby area onto the ground, whatever, that can still cause dangerous and damaging voltage disturbances, so that's just been expanded. Now this one, which is protective equipment, under voltage and or loss of voltage, so it can be under voltage and loss or under voltage or loss. This is slightly different because it used to say under voltage and no voltage. Just changing it say to loss of voltage rather than no, which is not particularly a major change. Now documentation 132.13, every electrical installation shall be provided with the appropriate documentation, including that required by this list of regulations, Part 6 and where applicable Part 7 and of course Part 8. Now we're going to see Part 8 coming up quite a lot, so that's an entirely new part, so of course it has implications for all of the things which are done generally. So Part 8, and of course prosumers electrical installations do need quite a bit of documentation, because this is the sort of system where you've got, say, generation and storage, so that's certainly important in terms of actually operating that. Now, the last one here of Part 1 is 134.2.1, and it's during erection and on completion of an installation or an addition or alteration to an installation, and before it's put into service, appropriate inspection and testing shall be carried out by one or more skilled persons competent to verify that the requirements of BS7671 have been met. And the changes here are that it's now one or more skilled persons. Previously it was just skilled persons, because of course it can just be one person, depending on the size of the installation really. So some small item it's likely to be one, but of course on a very large one it could be a whole load of people. And the other change here is that it now actually states BS7671, which of course is this particular standard. Previously it just said things like this standard. So this is another sort of tidying up thing where various inconsistencies have been resolved, so now it does actually state BS7671 rather than just saying this standard or various versions of. So there's not a huge amount of change in Part 1, but nevertheless there are subtle items there which have been amended, and a lot of what's changed in this particular one is sort of cleaning up and tidying up and removing things and sorting out stuff which really should have been sorted out many years ago. So it's about time, and good job for doing that. Now Part 2, which is definitions, as it says here, this has a variety of changes in, most of which is either new definitions or ones which have been slightly changed. The main deal, of course, is there's a lot of new ones, particularly for things like prosumers electrical installations. And in terms of definitions in general for electrotechnical items, you see at the top there it refers to IEC 60050. Now that particular standard is one of these you have to pay for, which is pretty much all of them, and it is rather expensive. However, you can actually see a version of that online on a website, and it's actually available for free. I'll put a link to that in the description, also on the screen here at the moment. So in terms of any definitions which are not included in here, and there's a lot of them, you can just simply go to that website, search for it, and then there it is for you. And those are sort of the official ones which are used in this standard and in many others, so something worthwhile knowing with that. Now, the first addition here is arc fault detection device. Now, despite these being included in previous versions, this is the first time it's actually been defined as to what it is. So an arc fault detection device, or AFDD, is a device intended to mitigate the effects of arcing faults by disconnecting the circuit when an arc fault is detected. Such devices include a single device having opening means able to open the protected circuit in specified conditions, or a single device with an integrated protective device, or a separate unit assembled on site with a declared protective device. And again, there are certain standards there which they need to comply with. Now, what this basically means is that a single device is going to be something you just buy as an arc fault detection device, and that's all it does. It doesn't have any other functionality. It is just for arc fault detection, so it doesn't have overload protection or RCDs or anything else built in. 2, a single device with an integrated protective device. That is probably the most common choice you're going to find. So it's an arc fault detection device combined with, in most cases, overcurrent, so the equivalent of a circuit breaker, and in many cases the equivalent of an RCD built in as well. And that's at the moment pretty much most of what you can actually buy. So it's an RCD, circuit breaker and arc fault detection all built into the same single unit. And then the third one, you can actually buy these. So it's a separate unit assembled on site. So essentially you're going to say buy a circuit breaker, and then there's a separate arc fault detection device which you can clip onto the side or attach in some fashion. So then it becomes effectively 0.2 there, so a combined device. So there's various ways that these things can be done. Obviously it's important to distinguish between these, because if you need to have overcurrent protection and arc fault detection, you don't want to just stick in an arc fault detection device which would leave the circuit wide open to overloads or overcurrent. So just like if you buy an RCD, you can buy an RCD as a separate item. That doesn't include overcurrent, and you can also buy an RCBO which includes the overcurrent protection and residual current detection as well. So a similar arrangement to that. That's just really a question of checking what you're buying and buying the appropriate device or devices. Now, a couple of new ones, and this provides into part 8 as well. So connected mode is an operating mode which needs connection to the public network. That can also be broken down into direct feeding mode and reverse feeding mode. And we've also got consumer of electricity, which is an entity or party which uses electricity for its own needs. We'll cover these again in part 8, which is in a later video. Now, consumer unit was defined in the previous one, but there is a change here. The main adjustment here is that it's a particular type of distribution board intended for operation by ordinary persons. Now, previously this suggested it was mainly for use in domestic premises, but now it doesn't say that. So it's just something which is intended for operation by ordinary persons, and it was comprised of a type-tested coordinated assembly. So the real changes here are that it's not specifically for domestic use. You could put a consumer unit in any other kind of property or any kind of premises. And the section about it being a type-tested coordinated assembly means that if you're going to buy a consumer unit from a particular manufacturer, in order to remain type-tested, you have to install in it devices from that same manufacturer. So you can't put another manufacturer's, say, circuit breaker into someone else's consumer unit, because if you do, it's then not a type-tested coordinated assembly anymore, because someone else's circuit breakers won't have been tested in it. They may well work, but that's not the point. It's not a type-tested assembly. So in theory, if you bought a consumer unit and then mixed around some of the circuit breakers with another manufacturer, it's not a consumer unit anymore. So an interesting change to the definition there. And again, you can put them in other places other than domestic premises. Now, a couple of new ones here. We've got direct feeding mode. Again, this fits into the part 8 as the other ones do. This is an operating mode in which the public network supplies the PEI, which is the prosumer's electrical installation. And again, we'll look at that in part 8. And we've also got a direct lightning strike. So lightning strike impacting a component of the network directly. A couple of examples there. Examples of components of the network are conductor, tower, substation, equipment, etc. And consequences of a direct lightning strike include the thermal, magnetic and mechanical effects of the discharge current, as well as surges resulting from its voltage drop along the discharge path. So this is where you've got lightning strikes on, say, a substation or transformer or something else, and that's going to cause obviously a large voltage disturbance on the network, and can also cause various other methods of damage as well. So that's now defined. Another new one here, distribution system operator, which is a party operating a distribution system. That is kind of what used to be called the DNO, or distribution network operator. It's DSO now, although the two aren't necessarily interchangeable, but DSO is really to indicate that it's not just a set of cables, it's an entire system of distribution. And again, this is going to fit in with things like Part 8, where you're not just taking energy and then distributing it to end users. It could, of course, can go back in the other direction with, say, people with their local generation or whatever going back into the system, and you're going to have a lot more entry points to the network now. It's not just ye old big coal power station generating electricity and shoving it into the grid. You've got many larger and smaller generation facilities putting it in at all different points. So DSO is another one. Another new one is efficiency measures, a level of implementation of measures to improve energy efficiency of an electrical installation. Now, bizarrely, efficiency measures are actually covered in a section of Part 8 which isn't included in this version, but nevertheless, efficiency is something which is important. And this could be as basic as determining the size of an electrical conductor for a circuit. If it's too small, although it may comply for other parts, it could actually waste energy. If it was, say, undersized, because you get obviously the heating effect when current goes through, and there's a whole load of other things there, but that is now a defined item. Electrical Energy Management System, or EMS, again this is covered in Part 8, so we'll see that later on. Generating set is now defined as equipment converting non-electrical energy into electricity, so that could cover a wide variety of items. Traditional sort of diesel generator obviously we covered, but again it could cover a variety of other things as well. Back to the over voltage or the lightning type things. Indirect lightning stroke is a lightning strike that does not impact directly any part of the network, but that induces an overvoltage in that network. Consequences of an indirect lightning stroke for electrical installations are the associated overvoltages and the energy content of the incoming surge wave. So this would be, as we saw previously in the other definition, a strike on a, say, transformer would be a direct one. Indirect lightning stroke could be, say, onto the ground somewhere, and of course that energy then is spread out through the ground, which could obviously impact cables and things, particularly if they were buried there or any other nearby equipment. So just because lightning doesn't actually strike directly onto a piece of electrical equipment doesn't mean it can't cause damage, because all that energy has to go somewhere, and say spreading out through the ground and imparting onto buried cables and similar. Another one from Part 8 is island mode, and that's operating mode in which the prosumer's electrical installation is disconnected from the public distribution system but remains energized. So that's where you can run your house from your batteries because the grid has gone away for some reason. And we also have load shedding, which is an approach where the electrical loads are switched off for variable periods of time to optimize demand. So if the grid is becoming overloaded, your smart home could decide to disconnect certain things like your hot water heater for a while to avoid the grid being overloaded or potentially going offline. Open circuit maximum voltage, which is the maximum voltage across an unloaded or open photovoltaic module, string or array, or on the DC side of that. So this is again fitting in with Part 8 and various other newer technologies. So essentially if you get a solar panel or set of panels on your roof, if you take the two ends of those wires and there's nothing connected, you're going to get a DC voltage there, and that's what open circuit maximum voltage is. And if you didn't know, it could be many hundreds of volts. So a lot of these are defining into sort of what's classed as new technologies, although of course things like solar panels aren't particularly new, but obviously adding them into here actually is. And then the other one here is operating mode, so again fits in with Part 8, so operation of an installation with respect to the different sources of electrical energy and to energy flow. So again it's solar, wind generation, battery storage, and so on. And fairly unsurprising, we've got prosumer's electrical installations and various variations of those all defined here. We'll cover those in Part 8 as well, so we're not going to cover those in much detail here. And another one important here is the protected escape route, which is a route enclosed with specified fire-resisting instruction designated for escape to a place of safety in the event of an emergency. Now this is important because some of the other things which we'll see later on do restrict what kind of cabling you can install in those particular locations. So examples of this could be, say, a corridor or somewhere like that, where essentially if you're leaving the building, that's the route you're going to be using to get out of there in the case of a fire or some other kind of emergency. And another one fitting in with Part 8 is the reverse feeding mode, operating mode in which the prosumer electrical installation supplies the public network. So that's when you've got battery storage or solar or something, and you're actually putting energy back into the grid rather than taking it from there. Now that's pretty much it for part 2. So we'll cover some of those definitions again later, but just be aware of those. Whether you're actually going to install this stuff or not, it is necessary to actually know what these things are, like PEI for example. So even if you may not be working on that type of system, it is necessary to actually know what these are, so at least you're aware of them. Therefore you know what people are talking about when you hear these things. Now the last bit we're going to look at in this particular video is part 3, assessment of general characteristics. This is fairly short and there isn't a huge amount of alteration there, but just have a quick look at a couple of minor items. 301 here. We've got this piece here which has been added. So assessment of general characteristics. These characteristics shall be taken into account in the choice of methods of protection for safety, covered in chapters 41 to 44, isolation switching, and the selection and direction of equipment. So it's just reinforcing the fact that these, which have always been here, need to be taken into account when referring to other sections there. And the only other thing in part 3 is this small bit here. So all that's happened here is we've now got parts 4 to 8. Again, part 8 being the new one. Previously it was parts 4 to 7. So again, part 8 obviously fits in with the rest of the book. And that's pretty much it for part 3. Various other minor bits there, just say it's referring to BS7671 rather than the words this standard, and a few other bits and pieces, but pretty much that is pretty much that. And the only thing we'll just quickly look at here, which is not actually change, it's 314. Division of installation. This is exactly the same as it was previously, and in fact most of this has been in here for the best part of 40 years. Most of this arrived in the 15th edition in 1981. A few changes since then, but this is something which a lot of people don't seem to realise exists, or if they do, they assume it only existed from last month. So pretty much what we've got here is that every installation shall be divided into circuits as necessary to avoid danger and minimise inconvenience in the event of a fault. And the other point here as well is that number 4 is to reduce the possibility of an unwanted tripping of RCDs due to excessive protective conductor or PE currents, not due to a fault. Now I'll say this is not particularly new, and the implications here are that if you're going to be installing, say, a consumer unit, you should divide it up as necessary to avoid danger and minimise inconvenience. Now, if you're going to install a consumer unit with, say, 1 RCD for the whole installation, pretty obviously that's not minimising inconvenience, because any kind of fault there, the RCD is off, all of the things in the installation are disconnected, and even things like an RCD, let's say 2 of them, half the installation on one, half on the other. Again, that's not really minimising inconvenience, is it? Because again, someone sticks a knife in the toaster and then half the circuits go out, including some of the lighting upstairs and all of that. So the reality of this is that consumer units with 2 RCDs in it, sort of splitting it into half, isn't complying with this, and in fact it hasn't been complying with this for many, many years. The proper answer, of course, is to put RCBOs in, so it is 1 per circuit, and then you are complying with this here, so it's dividing into circuits, and it is minimising inconvenience because it's 1 circuit, doesn't affect any of the others. Now, I'll say this isn't particularly new, but as we'll see in later videos, this has been reinforced in various other parts there, so the reality is that dual RCD consumer units are not compliant with this, and in reality haven't been compliant with this for many, many years. So if we're thinking of fitting those, then pretty much think again. Really, it's time for those to go away permanently. So that is it for this particular video. The parts 4 will be in the next version, but until then, thanks for watching.